Hi, welcome to another episode of Kinetic Crystal. I'm here to make science fun, and I'm an actual scientist.
So what are we learning today? Kinetic Crystal.
Today, we're going to be making a seismograph. And you may be asking, what is a seismograph? Don't worry, I'm going to teach you. But first, let me show you the materials you're going to need for today's experiment. A cardboard box, a plastic cup or styrofoam cup, a marker, scissors, tape, string, paper, and something like small rocks or coins to add some weight to our cup. Do you know what causes earthquakes? Earthquakes happen when pressure is built up in the Earth's crust and mantle, and it's pushing so hard that it slips or it slides, and it causes a jolt, and the Earth will shake. Now, that might not happen where you live, but in certain parts of the country, it definitely happens. Earthquakes are detected by using a seismograph, which is what we're going to make today. What we're making today is like an old-fashioned one, where today they're a little bit more advanced, where we're making a paper one. It's all now on the computer. Seismograph detects vibrations in the earth and their strength. A seismograph is securely mounted on the surface of the earth so that when the earth shakes, it moves except for that weighted section. So then the paper is shaking and your pen is supposed to stay still. So we're gonna see how that actually works. All right, let's make our seismograph. So first we're gonna take our box. I already started to cut the flaps off, but that is what you need to do. So let's finish that. Please be sure to ask for help. Now I have my box. Next, we're gonna take our cup and make a hole on each side. Again, please ask for help. So I'm just sticking it in there. Styrofoam is gonna be easier than plastic, I have a feeling. Okay, there's my two holes. And you also need a hole at the bottom. Okay, next, take 2 pieces of string. You're gonna tie each string, and your string needs to be longer than the length of the box. I now have 2 strings tied to my cup. You're gonna make 2 holes on the top of our box, the same distance as our cup. So I'm going to take my marker and mark where I should make the holes. I'm gonna make a hole there. Put your holes in the middle of that box. Okay, 2 holes. Now we need to tie the string. You want it to hang evenly. Okay, so I get my string through the top, and we want our cup to hang about 1 inch from the bottom, okay? And it needs to hang even. That looks good. So now I'm gonna tie my string together. Okay, so I have my string. You may need to adjust it, especially once we add the weight. Let's set this aside. I took some printer paper. I have 2 sheets right here, and you're gonna fold it in half, and then half again, and follow those lines to cut it. Once you have your papers cut, we're going to tape them end to end. This is going to be our paper that our seismograph is going to be recorded on. All right, I have a number together. Now you want to make slits on the bottom of our boxes where this is going to feed through, so it needs to be that wide. It's not the prettiest hole, but it will work. You see it? I'm going to do it to both sides. All right, so I have my 2 holes. Should fit my paper. So now you want to put your paper through. Okay, it looks good. Now you want to put your marker through your cup, and you just want a little bit sticking through where it's just touching your paper. It needs to stand up straight, so that's why we're going to add our weight around it. I need to tie this tighter. That looks okay. Now that we have our seismograph made, I'm gonna tape it to the table so that it will simulate it being connected to the earth, and then we'll have the table be what shakes, and we'll see what our graph looks like. I encourage you to have a friend. One person is going to shake the box or the table, and the other is going to move your paper so that we can see our line. So are we ready to test our seismograph? All right, I believe my pen is perfectly where it needs to be, and let's start with just a small little bit of shaking and moving our paper. You're gonna stop and pull so you can see what it looks like when there's no earthquake. Then we'll shake it again. It's not not perfect, but it still shows exactly what a seismograph does. The recording of the shaking is called a seismogram. So that's exactly what we made. This is when it was not shaking and when it shakes a little and then it shakes a lot. The strength of an earthquake is measured on the Richter scale. It's measuring the peaks of how high these are. So the bigger the peak, the higher the number. And the scale only from 0 to 9. 0 is nothing happening, like in this spot. And then we have a peak here that it would get measured. And then all of these would get measured. And it shows the intensity of the earthquake. Well, I hope you had fun today making a seismograph. I know it was a little difficult, but I hope you find that it was worth it and you were able to make a seismogram and you can make your own little earthquake. Please like and subscribe so you can see what happens next week on Kinetic Crystal.
You can always figure out collecting facts and observations and testing hypotheses. You take your results and compare to see what else there is. And after you fully understand everything you're hearing, you can put it all together in a scientific theory. Kinetic crystal, kinetic crystal, kinetic crystal, kinetic